All right, welcome to Solar Angle Lab for Geology 120. So what we're looking at in this lab is how the angle of the sun relates to how quickly the planet gets hot and how, in the absence of sun, how quickly the planet cools down. Um, I think it's kind of awesome that we are talking about so the first part of the lab is just a little reading exercise. I try to weave a little bit of art and literature into these labs whenever possible and practical to do so. And I thought it'd be important for people to think a little more deeply about their shadows on the first page. So there's nothing you actually have to turn in here. It's just sort of to make you think about life. Now, this part two of the lab, it used to be we had a sundial we could go to in the Greater City College campus. It was literally right outside the door of our lab room, and it looked like this from up above. And it was really awesome. You could actually use it to tell the approximate time of day. So it turns out there are sundials all over the place if you know where to look. And this is a picture that my wife took of me. Hey, check it out. Like the shirt? This is me on summer solstice of this year out in Santee, California. There's a sundial where if you depending on where you stand, where if you stand on the proper month of the year, your shadow and stand up straight. Maybe I should be working on the posture. Your shadow will point to the proper time of day. And what's cool about this sundial is that it actually has numbers for daylight savings time and numbers for standard time. But there's a couple of things I want to point out about the sundial. So the first thing is you can't really see it in this picture clearly, but I'm standing on the Junes. Each of these squares is labeled with a different month of the year. And depending on which, and I'm standing on the June square. If you might, as you might imagine, the December square would be somewhere all the way back over on this far end over here, because in December, you're going to be casting a much longer shadow than the shadow you're going to be casting in June because of the interaction between our axial tilt and the sun. All right, so for this first part of the lab, this first part of the lab is designed because of the time we live in to be doable even if you are just inside your house and all you have is a window. So this will be interesting. Let's see what we can do here. So what you're going to want to do for this first part of the lab is go to a window, just a moment. And you can also go out in the street to do this or not. And what you want to do is look for a tall, straight object that casts a shadow. A couple good candidates that I see here is this telephone pole across the street from me. I also see, ooh, there's a nice little not a through street sign at the end there. That might be a good candidate. A couple of these palm trees are looking pretty good. Yeah, there we go. There's a nice palm tree shadow outside my door. Whoops. Yep. Outside. And what you want to do is you'll see on the second page of your lab handout several times of day. So what you want to do is do this experiment. You can either do it all in one day or you can do it over the course of several days. And if you don't have the schedule that allows you to stay sort of in one spot for all that time, feel free to do different times. Just mark those times differently and try to sample at least a 3-hour interval of time. So again, this is something you can do well. Oh, here we go. Sorry, I always have to do that. One of those flies over me. So yeah. And what I want you to notice is one, how long is the shadow? Two, what direction does that shadow point as the day goes on? So here it is, it's October 21st, and it's about 3 in the afternoon right now. And we have a nice sort of long shadow pointing at that's So in this case, that telephone pole is about so high, and that's so high. Feel free to estimate how long the shadow is if you don't have an accurate means to measure it. But definitely notice length. So I noticed that, oh, that shadow is going all the way past where the curb's turning red and where that Fiesta, and I know for a fact that Fiesta's not likely to move in the next day or so. Yep. And just sort of, and then what you want to do is every hour and a half, you want to note it, take another note of the position. You can even do something like take pictures of the shadow and then of the same spot, the same angle, and try to note that. And make some hypotheses about why it is the position of the shadow changes throughout the day. All right. So that's the first part of that lab there. And so my goal is, again, to sort of get you acquainted with the fact that there are many sort of not exactly natural sundials, but yes, sundial-like objects all around you. All right, I'm gonna leave the meeting in the capacity of my phone here. So then for the second part of lab, you're going to be looking at the temperature range throughout the day. So this is a graph of temperature versus time for San Diego, California. And you're just going to be answering a couple questions about when is the temperature highest, when is it lowest, and how does that temperature correlate with the length of the shadows you observe. And so I have one graph here for San Diego, but I also thought it might be good to get a graph for, oh, somewhere a little bit further inland. So I also got some data from El Centro, California. And hopefully you're noticing already a major difference between between San Diego and El Centro. Hint, check out the y-axis. And then what you want to do is note the length, how the temperature range varies in January, which is the blue, orange, which is April, gray, which is July, and yellow, which is October. And look at this sort of and take some notes about this graph of temperatures. And you're also going to be looking at the same graph for San Diego. So hopefully so far this is all fairly straightforward. My goal for the next couple weeks is to make the labs about much shorter. So that's it. Then what you want to do is look at a model. So what I've included this third part of the lab is a model of the Earth system. So if you click on this, you should see a temperature map of our planet. And what's cool about this is you can click anywhere and it'll tell you the temperature. Now, a lot of people don't like Celsius. You can always click on the C and hey, there we go. We got Fahrenheit. If you prefer Kelvin scale, go for it. I'm going to use Fahrenheit just because that's the most friendly terms for us. And you'll sort of notice a couple things. You can see the land masses. Hopefully everybody can see we're right about here. Hopefully everybody knows that this is the southern hemisphere down through here. This is the northern hemisphere. And if you click and drag, you can manipulate this and focus in on different places. If you use the wheel on your mouse here, you can zoom in and out. This will give you little bits of information. This again is a map of temperatures right now. Now, the other thing I'd like to just point out is one of the questions on here is going to ask you about the nighttime temperature. So here we are at San Diego. We're at about 30 degrees north. About the same latitude somewhere in the Middle East or Iran. In fact, we're, yeah. So if you look at a spot about 180 degrees away, Yeah. You might notice that, yep, it is a little bit cooler at the same latitude and same distance from the ocean if you're on the other side of the world. So try to figure out how all these factors might matter and try to think about it. It's not these questions are generally open-ended, but I hope you notice some difference between what's happening on the land masses, like here in Central Australia, versus what's happening in the oceans surrounding Australia. And yes, there's also a bunch of arrows indicating wind direction. Like I say, that is there. And so once you answer those questions, then you're going to look at model results for summer. Oh, wow. It is really hot in the Middle East in July. Jeez. Wow. Kuwait and southern Iran are freaking pressure cookers in this thing. Yep, that's hot. Kuwait is very hot in this model here. Cool. As is northern Pakistan. Yeah. Hmm. Versus winter. And so hopefully you sort of start to notice different patterns in the temperature. That's the goal. Right. So finally, for part four, read it. You don't actually have to do any of the exercises in here. This is a sort of classroom exercise I designed last year to help people get a better sense of sort of how sun angle is going to vary with the orbit. So if you got a fidget spinner for the lab, this is one of those chances to really whip it out and have some fun with it. And I want you to sort of notice a couple things about your fidget spinner. How many people got their fidget spinners? Yeah, here we go. So what you do is compare, see how I'm moving this fidget spinner around like this? I have it a little bit tilted. And I want you to compare the motion you have when the fidget spinner is tilted and you keep the tilt pointing the same direction versus what happens when the fidget spinner wobbles. And again, this is a completely optional exercise, but hey, who wouldn't want to have more chance to play with the fidget spinner? That's my thought anyway. Oh, here, I've got a better one. This one's a little bit rusty. So, oh, yeah, here's the good one. And yes, I do literally have a box of 25 of these somewhere. This one's actually a little wobbly. Okay, yeah. So notice if you move this around like so, it's not going to feel like a very intuitive motion. And what you're going to feel is the fidget spinner is going to want to be sort of be resisting the motion you put on it. Yeah, this one's got a little bit less lopsided. I'm not sure what happened to that one, but okay. There's a good one. Yep. And so you'll notice it feels a lot more natural when the axis spins. Now, the other cool thing is if you hold a fidget spinner long enough, it will start to wobble on you. Um, yeah, it'll start to wobble, and that's actually also explains some more complex, nuanced behavior of the Earth system that we're not going to get into quite yet because I want to make sure everyone understands this bit of things. And finally, when you're done with that, so you don't actually have to write anything down here. This is just sort of like a sample exercise on activities that are kind of fun to teach kids. The only question you actually have to answer is this one here. Would this be a fun activity to do with students and why? Then the last part here is an activity we call Sundials of the World. Let's see if I can shrink this down. Why? Yeah, there we go. So we're looking at here are these are different Google Earth images taken of sundials at different points, places around the world, including places like City College. So you can see our sundial. Hopefully everybody recognizes B Street here. We have Stonehenge taken very close to summer solstice. You can really see the way those shadows do trippy things. I also have one at Muscat, Oman. In case you're wondering where Muscat, Oman is, or you wonder what other things these are, place the name into the into here. And the cool thing about Muscat, Oman is that it's right on the Tropic of Cancer. Or the Tropic of Cancer, the northernmost point in the northernmost latitude to experience direct sunlight, runs pretty much directly through here. I think it's actually about 23.5 degrees or something like that. So it's actually technically a touch south. But the cool thing about this is one of the cool things about the Middle East and Muslim countries in general is that the worship houses have these beautiful tall minarets and spires. And those tall minarets, I mean, church buildings are great too, but the ones used for the mosques are tall and pointy and make great natural sundials. I almost have to wonder if somebody in the early days of the faith kind of thought about that, because I know the Middle East is where we got algebra and a number of other um, ideas about higher order math. So I don't want to speculate too much, but let's see if I can find it. Definitely. Oh, here's the airport. Yep. And so what's cool about that is you'll notice for the Muscat one, there's almost no shadow. I'm trying to find the mosque here, but oh, there it is. Yes, yes, they something caboose. Oh yeah. So here you can tell this was definitely not taken during summer solstice, but yeah. But notice how small the shadows are. So you can again use this information to figure out approximately what time of year and what time of day this satellite photo was taken. And I love this one. It's got like actually four of these little tall towers on it. So yeah. All right. I also decided to give you Carhenge because hey, why not give Carhenge Carhenge is in Alliance, Nebraska, and you might see very different shadows at Carhenge than you see at Stonehenge. Oh, check it out. Look, here's one Muscat, Oman in September. Notice how September, the shadows are very different from here. And and it doesn't have to be a religious place to cast a shadow. Our very own Washington Monument also has a very distinctive shadow, and that shadow is going to look very different in December than it's going to look in July. And finally, I threw in one or two places that are in the southern hemisphere. And so this lab should be one of the shortest labs you've done all semester. And I'm going to stop the recording.